Alright, we're going to begin our series on chemical nomenclature, which is naming molecules. So before we dive into that, we need to actually be able to diagram what a chemical formula looks like. A formula represents the number and kinds of atoms and the smallest particle that displays all the properties of the substance. The cation is always written first and the anion is always written second. Remember that the cation is the positively charged ion and the anion is the negatively charged ion. Okay? Subscript. Sub means below and script means to write. So what a subscript does is tells us the number of each atom in a formula, and it's going to be located below the atomic symbol for that element. Okay? All compounds are neutral, and so the sum of their oxidation numbers must be 0. Remember, oxidation numbers are the charges that we get when an element is ionized or becomes an ion. So let's just take a look at an example here. I'm going to do an example formula for us. Okay, so this whole thing right here is a chemical formula. Alright, now the calcium is the cation because the cations are always written first, and the bromine is the anion because anions are always written second. Okay, now this entire formula here is neutral. It has 0 charge. The element calcium, so the solid metal calcium, has 0 charge. Okay? And the element bromine has 0 charge as well. But when we put them together to form a salt, because remember, metals and nonmetals form salts, they ionize. So this is an ion here and that's an ion there. Calcium has a +2 charge, okay, and bromine has a -1 charge. Alright? Now we have 2 bromines. So 2 times -1 gives us -2. And that -2 cancels out with this +2 so that we can have a 0 charge overall. Okay? This 2 right here is a subscript. Okay? It's telling me that I have 2 bromines. There is an understood 1 right here. Okay? We don't have to write that. In fact, you're not supposed to write it. Okay? The simple fact that we wrote Ca tells us that there has to be at least 1 calcium there. If there were more than 1, then we would write that number. But if there's just 1 of something, you don't have to put a 1 subscript. But it is there. You just don't have to write it. Okay, so why don't we fill out our oxidation states on your periodic table. Okay, so get your periodic table out. And above each of the columns, I want you to go through and write the oxidation states that are possible for all the elements in that column. Okay, so we have +1, +2, plus or minus 3, plus or minus 4, -3, -2, -1, and 0. Notice that hydrogen over here, it can be a -1 as well. Now your periodic table doesn't look like that. It doesn't have a hydrogen over here. So you need to either add it in or write yourself a little reminder that hydrogen can be a -1 also. Okay? You need to memorize these. You need to be able to quickly look at your periodic table and know that calcium is a +2 because it's in that second column. Okay? Now, for these two that are plus and minus, you might be asking yourself, well, how do I know when these elements are going to be +3 or when they're going to be -3? The answer to that question is it depends on if it was written first or if it was written second in the formula. Remember, cations are written first, so if boron is in one of the molecules you're trying to name and it came first, then it's got the +3 charge. If it was written second, then it's going to have the -3 charge. Okay, the next thing we're going to learn is the crisscross and reduce. Okay, so anytime that they give you two elements or that you need to stick together, you're going to figure out what the charge on that element is from the periodic table. That's what we just wrote down. And then you're going to do what I call crisscross and reduce. So you're going to drag the number down to the opposite side. You're not going to take the sign that goes with the number. So you're not going to drag +3 down, you're just going to drag 3. And you're not going to drag -2 down, you're just going to drag 2. Okay? And then you push them together. Now here's what that's actually doing, okay? We said that all compounds have to stay neutral, right? That means that their charges have to add up to be 0. Okay, so if you have aluminum and it's got a +3 charge, and we have oxygen and it's got a -2 charge, you'll notice that those don't cancel each other out right now. So if we were to just shove those two things together, our final compound would not be neutral. So what we're doing here when we drag these numbers down is we're really multiplying in order to get us a neutral number. So watch this. We have two aluminums and each of them have a +3 charge. So altogether we have a +6 charge on this side. Over here we now have 3 oxygens and each of them are -2 charge. So altogether over here we have -6. And that means that the +6 and -6 cancel out and give us a neutral molecule. That's why we have to crisscross in the first place, is so that everything will add up to be 0 charge-wise. Okay? Okay, let's see if we can practice one of those. Let's say that we want to put lead together with sulfur to create a compound. Okay? The first thing that you have to do is get the charges of these elements. Okay, so lead is right here and it's in the plus or -4 column. Since it was written first, it's going to have a +4 charge. Sulfur is written in the -2 column, so it's going to have a -2 charge. Alright, so we're going to bring down our charges here. Alright, the next thing that we have to do is crisscross and reduce. Alright, so we're going to bring the 4 down to the sulfur and we're going to bring the 2 down to the lead. Okay, so we just did the crisscross, okay, and now comes the reduce part of the system. We have a 2 here and we have a 4 here. Those will go into each other evenly, okay? So the 2 I can divide by 2 and get 1, and I can divide 4 by 2 and get 2. Okay, so I have reduced now, but I have this 1. Remember, that's an understood one, and we don't really need to write it. Okay, so we're going to drop the 1, and then we just shove everything together. And here is our final answer. Okay, so we have PbS2. Okay, let's see if we can do some practice ones together. Alright, sodium has a +1 charge. Chlorine has a -1 charge. So when I crisscross, I'm going to get Na1Cl1. And ones are understood, so I can just ignore them. So that's what I come up with for the first one. Okay? Alright, let's see if we can do another one. Beryllium is a +2 charge, and silicon is a -4 charge. Alright, so let's see what we get when we crisscross. Okay, I'm going to bring down the beryllium, I'm going to bring down the silicon, drag the 2 down, and we drag the 4 down. Okay, and then those will reduce into each other. 2s and 4s will reduce. So our final answer then is going to be Be2Si. And we don't need to put Si1 because that's understood. Okay? So I'd like you to go through and complete the rest of these through number 10. This is also in your note packet, so you could do it there and have the space. Okay, so you can check your answers here. Hopefully you came up with the same thing as I did. The 2 crisscrosses down and the 1 crisscrosses down, but the 1 is understood, so you don't have to write it. So there's our formula. Here, the 2 crisscrosses on both, we can reduce them, and here's our final answer. Here the 2 comes down and the 4 comes down, those can reduce, so there we go. Here the 1's crisscross down, but they're understood and we don't write them, so there's the final answer. Here the 3 comes down and the 1 comes down. We don't have to write the 1, so that's the final answer. And then finally the 4 comes down and the 2 comes down. Those will reduce, and here's our final answer. Okay? Okay, so what we've been looking at so far are called binary compounds. Alright? Bi means 2. Okay, so binary compounds are going to have 2 elements only. Alright? They're going to have 2 elements only. Okay, and then here's kind of the rules for binary compounds. Every single binary compound will end with IDE, or it will begin with hydro and end with ic acid. Okay? There are 3 kinds of binary compounds that we're going to learn. Alright? In order to be successful in nomenclature, there's going to be a lot of memorization, and you're going to hear me say, here's the rule, never ever break it, except, and then I'll give you a situation in which you can break it, okay? Every single time that I tell you a rule, there's going to be an exception to that rule, okay? And so that's just going to give us a lot of memory work that we're going to have to be willing to do, okay? Alright, the first thing that I'm going to have you memorize is what's in this box right here. These are exceptions to the binary rule. Okay, I told you that binary compounds will only contain 2 elements. These are exceptions to that. Okay, OH minus 1 will function as an anion, okay, by itself. So normally we have the cation written first and the anion written second. Okay, so that would be our cation and this would be our anion. Okay, notice how there's only 2 kinds of elements here. There's a calcium element and there's a bromine element. Well, these exceptions right down here have 2 elements together functioning as the anion. So we might have something that looks like this. Alright, so here would be our cation and here would be our anion. Both of these are binary compounds, even though this one right here actually has 3 different elements in it rather than just the 2. Okay, so these will function as anions. They are exceptions to the rule, and you need to know them. So you need to know OH minus 1 is the hydroxide ion. You need to know that Cn minus 1 is the cyanide ion. And you need to know NH4 plus 1 is the ammonium ion. And that they are counted as a single element for the purposes of naming. Okay, that's why we can still say this is a binary compound. Even though it's got 3 different elements in it, this is considered to just function as one element. Okay? So let's look at the first rule for naming binary compounds. If the first element is a metal, here's the rule. You're going to say the name of the first element, then you're going to say the stem of the second element, and then you're going to finish it off with IDE. Now you were given a nomenclature flowchart, okay? And you can either use the flowchart or you can use your notes during this nomenclature section to help you name things until you've got everything memorized. They both have all of the information that you're going to need. So your exceptions are up here in the top left-hand corner, and we are on the binary side of the flowchart right now. So the first thing that we are looking at right now is the first element, a metal. And it says here with only 1 oxidation state. We'll talk about that in just a little bit. Okay? The rule, start with the name of the first element, say the stem of the second element, and then add IDE. Okay, so what are we talking about when we say stem? All right, the stem is going to be like the first half of the element's name, and it will change depending on what kind of molecule we're naming, and I will alert you to that. And this part of it is just kind of going to take some getting used to. You had to practice and hear several different names before you start clicking in on what's the stem. So don't worry about that so much in the beginning. I will definitely help you along. Let's do some practice with this first rule here. Okay, so here's 3 quick problems that we can apply this rule to. First one up here, okay? Is it binary? Is the first question you need to ask yourself. Yes, this is binary because there's only 2 types of elements there, okay? The second question is the first element a metal? See, the only rule we have so far is if the first element is a metal, okay? So, is sodium a metal? You look on your periodic table and remember, anything to the left of that stair-step line is a metal. So yes, sodium is a metal, which means we can apply our new rule here. And that rule says that you say the name of the first element, then the stem of the second element, and then add IDE. So let's give it a try. Alright, we've got sodium. Then we have chlor, that's the stem for chlorine. And then we add IDE, so we get sodium chloride. Okay? Let's see about number 2. Alright, we need to write the name of the first element because this is binary and the first element, calcium, is a metal. So we're going to write calcium. Okay, now we need the stem of the second element. Okay, the second element's bromine, so the stem for that is going to be brome. And then we're going to add IDE to the end. So we end up with calcium bromide. Okay, so then that brings us to our third question here. All right, I want you to see if maybe you can figure this one out. So I'll give you a second and then I'll walk you through it. Okay, so the first thing we're going to do is ask, is this binary? Yes, there's only 2 kinds of elements. The second thing we're going to do is figure out if the first element's a metal. Yes, aluminum's a metal, so we get to use our rule here. We're going to say the name of the first element, okay, and then we need to say the stem of sulfur. Alright, when we're working with salts like this, metal and non-metal, the stem for sulfur is going to be sulf. And then we add IDE to the end. So we end up with aluminum sulfide. Did you get what I got? I hope so. Okay, so as you work more and more, the stems of the second elements will become more easy to figure out. Okay? Alright, well I told you, every time I give you a rule, I'm going to give you an exception, okay? If the metal has more than a single oxidation state, then the rule changes. Now what am I talking about, more than a single oxidation state? Okay, well the metals that we just worked with had 1 oxidation state because they were in one of these columns that I've already talked about here. So they were either +1 or +2 or +3 or +4. Okay? Now, you'll notice, hopefully, we skipped all these guys in the middle here. And the reason for that is because they have more than 1 possible oxidation state. These guys over here can only be +2. That's it. But these in here have multiple oxidation states that they can be. And so we're going to have to figure out what those oxidation states are, and then we'll have a rule for naming them. Okay? So here's the rule. If the metal has more than a single oxidation state, then the rule is, say the name of the first element, which would be the metal, then you're going to put the oxidation state of that metal in Roman numerals and enclose it with parentheses. Then you're going to say the stem of the second element, and then you're going to have IDE. Now this is called the systematic naming system, okay? So this one right up here is the systematic naming system. That's the one that uses Roman numerals. There's a second way of doing it, alright, and that's going to be the common naming system, which is this one right here. And we'll get to that one in just a little bit, but I want to practice the systematic one with you first, okay? In order to use this systematic naming system, we've got to know the oxidation number. So we're going to look at some elements down here that are going to give us the oxidation state for those middle elements, those transition metals. Okay, so you need to memorize the oxidation states for these elements here, okay? I'm going to take a few off the list for regular or on-level chemistry classes. Pre-AP students, you need to know them all. But on-level students, you don't need to know vanadium, so you can cancel that off of the list. And I think that's everything actually. So pre-AP, you just need to add vanadium into your repertoire. Okay, so these elements here can be a +2 and a +3. These can be +2 and a +1. These two are only going to be a +2 charge. Silver is a +1 only, so it actually does not use the systematic or the common naming system. You go back to the original, because this one, and actually these two also, they only have one possible oxidation state, not more than one. And then these over here have +2 or +4 as possibilities. Okay, so here's your periodic table. Some of you may prefer to memorize the chart that we just showed you, or you may prefer to go through the periodic table and number it. I want to just draw your attention to a couple of things here. On your copy of the periodic table, if you look in here at each of these boxes, hopefully you'll notice that you have these numbers over to the side of your atomic symbol. These numbers represent the possible oxidation states for that element, okay? So what we're going to go through here in a second is what I call the 2-3-2-3s, and the reason I call it that is because the first few elements here have 2-3 oxidation state, okay? So we're going to go through this together and learn our oxidation states for our transition elements, okay? Now, pre-AP kids, you're going to start here at vanadium. On-level kids, you're going to start at chromium, okay? So, it goes 2-3, 2-3, 2-3, 2-3, 2-3. Alright, so all of these first elements here, all the way up to nickel, are going to be 2-3 oxidation state, okay? Then copper is going to be 1-2. And then right next to copper and right below copper is a 1 and a 2. Alright, so copper is together 1-2. Zinc is just a 2. Silver is just a 1. Okay? And cadmium is just a 2. Alright? So this section here I kind of remember because they all have oxidation numbers that are the same thing as what copper has. So copper is a 1 and a 2. Right next to it's a 2. Right below it's a 1. And then right here it's 1, 2. Okay? Gold is a 1-3. Mercury is a 1-2. And then we come over here to tin and lead, and we have 2-4, 2-4. Okay, and that's all the ones you have to know. So if we go through our 2-3, 2-3s, this is what we'll do, and we'll practice this over and over in class. Okay, 2-3, 2-3, 2-3, 2-3, 2-3, 1-2, 2, 1, 2, 1-3, 1-2, 2-4, 2-4. You need to be able to go through that on your own really fast. Okay, you need to memorize it and have it down well enough that you can just rocket through that to the point where you don't even need to look at the periodic table anymore. You know what those oxidation states are. So you can choose to use the periodic table to learn that, or you can learn it out of the chart that we looked at a minute ago. Okay, so let's see if we can practice naming some with our new rule here. Okay, so here's some practice questions for us. The first one we have here, Fe2S3. Okay, let's go through our rule. Is this a binary compound? Yes, because there's only two elements here. Is the first element a metal? Yes. Does that metal have more than one oxidation state? Yes. Iron is a transition metal. It was in that middle section on the periodic table, so it definitely has more than one oxidation state. Okay? So if we're following along on our flow chart, we're on the binary side. We have first element metal with more than one oxidation state. So we're in this right here. Here's the rule for the systematic naming system. We'll say the name of the first element, put the Roman numerals of the oxidation state in parentheses, say the stem of the second element, and then end it with IDE. So we'll say the name of the first element, iron. Then we need to say what the oxidation state of iron is in this molecule. Okay? Iron has the possibility of being a +2 or a +3 charge. So we have to figure out which one is this iron. Okay, and in order to do that, we're going to uncrisscross and reduce this molecule. Okay, the 3 on this sulfur, if I uncrisscross it, that means it must have come from iron. And the 2 here on the iron must have come from sulfur. Okay, so the version of iron that we have here is the +3 version. Alright, so we're going to put the Roman numeral 3 in parentheses. Okay, then the next part of the rule is to say the stem of the second element. Okay, so the stem for sulfur, when it's in a salt, is going to be sulf. And then, as with all binary compounds, we end with IDE. Okay, so we have iron 3 sulfide as the name of this molecule, and this is the systematic name. Okay, let's take a look at the Roman numerals here. I know that y'all probably don't get taught this very much anymore, so I wanted to introduce you to it so that you know what you're supposed to write when you're trying to do an oxidation number. This table has way more than what you're ever going to need. The maximum you will probably ever do would be 7. In this class specifically, you probably are only going to go up to 4. Pre-AP kids, you may do 5, 6, and 7, but I'm not sure about that. So let's talk about what you do. In Roman numerals, you use letters, so we have I's and V's that we're going to focus on. You do a single I for 1, 2 for 2, 3 for 3, and then 4 is based off of the number 5. So the number 5 is the capital letter V. So for 4, you put an I before the V, and that means 1 less than 5. For 6, you do an I after the V, and that means 1 more than 5. And 7, you do 2 after. So you really just need to know these 7 Roman numerals here, and you should be good to go. Alright, so let's try the second question here. Is this binary? Yes, because it's got 2 elements only. Is the first element a metal? Yes. Does that metal have more than one oxidation state? Yes. So we're going to say the name of the first element, chromium. Then we need to put the oxidation state of chromium in parentheses using Roman numerals. So what are the possible oxidation states of chromium? Well, if we look at our periodic table here, we've got chromium, and if we zoom in, you can see we have a 2 and a 3 oxidation state that you're responsible for knowing. So how do we know which one of them this version of chromium is? Well, just like above, we're going to have to uncrisscross. This one's a little bit more complicated though, because you'll see that both of the subscripts are 1s. So we know that chromium's a +2 or a +3. We just don't know which one yet. The phosphorus is a -3 if you look on the periodic table. That means that we should have brought a 3 down here, but you'll notice there's not a 3. The reason for that is because we must have brought down the 3 version of chromium, and then they canceled each other out to become 1s, which are understood and are not written. That means we must have the +3 version of chromium. So we're going to write that in parentheses out here using Roman numerals. Then we say the stem of the second element, which is phosp, and then we finish with IDE. Okay, so now let's try doing the third one. Is this binary? Yes, it is. Is the first element metal? Yes, it is. Does it have more than one oxidation state? Yes, it does. So we're going to say the name of the first element. Then we're going to put the oxidation state in parentheses using Roman numerals. So nickel can be a +2 or +3. Okay, there must have been a +3 version because that's where that 3 comes from on the chlorine. Okay, so we'll put that in Roman numerals. Then we need to do the stem of the second element, which is chlor, and then we finish with IDE. So altogether we get nickel 3 chloride. Alright, let's talk about this common naming system. This is going to require you to know the metal ion names, which I will tell you in a minute. And the greater oxidation number will cause the metal ion name to end with "ic", and the lesser oxidation will cause it to end with "us". Okay, here are the elements that have common names, and they are matched up with their common ion names. Here's how they got those common ion names. They took the stem of the Latin name, and then "ic" is for the higher oxidation state, and "us" is for the lower oxidation state. These are the Latin names for the first 4 elements in our list. Copper is cuprum, iron is ferrum, tin is stannum, and lead is plumbum. Now, mercury and chromium are a little different. Mercury's Latin name is hydragyrum, but for the common naming system, we just abbreviate from mercury, so we have merc. And then chromium doesn't have a Latin name. It actually comes from the Greek word chroma, so we just take the stem of chromium and have chrome for our Latin stem, if you will. Okay, so if we use copper here as our example, here's the +1 version, here's the +2. "Ic" is for the higher oxidation state, so the 2 is higher or larger than 1, so the ending is "ic" here, and "us" for the 1. Okay, so let's see if we can go back to the practice questions we just did and name them with the common naming system. Alright, so of our 3 questions, only the first 2 have a common name. Nickel does not have a common name, so we won't be able to do that one, but we can do the first 2. So we're going to use the rule for the common naming system, which is to say the name of the metal ion, the stem of the second element, and then IDE. So we need the stem for this iron ion. It's the +3 version, so we're going to say the stem of the Latin name of iron, which is Fer, and then since it's the +3 version, it gets to end with "ic". Then we're going to say the stem of the second element, which is Sulf, and then we're going to end with IDE. Okay, so we have 2 possible names here, the systematic and the common. On a homework assignment, a quiz, or a test, you will need both names in order to receive any credit at all. There is no partial credit. If a compound has 2 names, you must give both. Alright, let's do the second question here. Chromium, we need its ion name, and so we're going to say the stem for chromium, which is chrome. Okay, and then earlier we deduced that this was the +3 version of chromium, so that means we get to end with "ic". Then we're going to say the stem of the second element, which is phosp, and then we finish with IDE. If you're following along on your flowchart, we're on the binary side, and we're down here at common name. We have the metal ion name, then ic for the larger oxidation state, us for the smaller one, and ending with IDE. You'll notice I have two asterisks here. That's directing me towards this box of metal ion names. Here are all of the elements that you have to know that have common ion names and the stems of their Latin name. And then you'll just have to decide, does it end with ic or us. Alright, the second type of binary compound you could have is one that has a first element of a non-metal. So here's the rule. You say a prefix, you say the name of the first element, prefix of the second element, the stem of the second element, and then IDE. A prefix is indicating the subscript for each element. So here's a list of prefixes. Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta 7, octa 8, nona 9, deca 10. Mono has a bit of a special rule. You only use it on the second element. You do not ever use it on the first. And I've included an example here of when you would see it, carbon monoxide. That doesn't mean that that's the only time you would ever see it. There could be other compounds out there, but when you do see it, it's only used on the second element, never the first. Okay, as I told you, there's always an exception to the rule, so these prefixes have an exception. If a prefix ends with the letter A, which you'll notice that most of them do, and that prefix happens to be placed next to a stem that begins with a vowel, then you need to drop the A off of the prefix so that two vowels are not placed next to each other. Here's an example. We have sulfur tetroxide. Notice that the A of tetra has been removed so that we don't have an A and an O sitting next to each other. This sounds weird when you say it, sulfur tetraoxide. And it doesn't flow as easily as sulfur tetroxide does. So make sure that you remember this rule here. Okay, let's do some practice questions here. We'll do the first one. Is this a binary compound? Yes, because there's only two elements. So we're going to use our new rule. Prefix, name of first element, prefix, stem of second element, and then IDE. So if you're following along in your flowchart, we're on the binary side. We're over here at first element non-metal. We have prefix plus the name of the first element, prefix plus the stem of the second element, and then we end with IDE. You'll notice we have one asterisk, which is pointing to this box of prefixes, so I have them all listed here for you. I've included a couple of more. 11 is undeca and 12 is dodeca. It looks like I missed the A off of undeca, so you'll need to add that in. And then I've reminded you that you only use mono on the second element and never for the first. It's rare that I'll use 11 and 12, but you still need to know them just in case I choose to use them. So the subscript is 2, which has a prefix of di. Then you say the first element, nitrogen. Notice that the D is capitalized and the N is not. The prefix becomes the beginning of the name. Now we'll do the prefix for the subscript on the second element. So 5 has a prefix of penta. Then we do the stem of the second element, which would be ox for oxygen. However, we notice that the O in oxygen would be sitting right next to the A in penta. That's two vowels sitting next to each other. So we need to drop the A off of penta and add ox. Then we finish off with IDE. Okay, let's do the next one. We have CCl4. So the first thing we would do is the prefix for the first element. So the first element has a subscript of 1, which has a prefix of mono, but you don't use mono for the first element, so we'll skip straight to the name of the first element. Then we'll do the prefix for the second element, so the 4 subscript has a prefix of tetra. Then we'll do the stem of the second element, which is chlor, and then we'll finish with IDE. Okay, now you do the next one. Okay, hopefully you came up with sulfur trioxide. You don't use mono for the first element, so you go straight to saying sulfur. Then the 3 subscript leads to a tri prefix. Oxygen has a stem of ox, and then you finish with IDE. Okay, the third and final type of binary compound you could have would be an acid. Anytime the first element is hydrogen, you have an acid, and there is no exception to that rule. It doesn't matter what kind of compound we're dealing with, if it starts with a hydrogen, it's an acid. Okay, we have 2 ways that we could be shown an acid. If we are given an acid in the gaseous state, then we're going to name it as though it's a first element metal. If it's an aqueous acid, meaning it's dissolved in water, then you'll use this new rule here to name the acid. Okay, so we have some examples here. This little g indicates that it is a gaseous acid. Here we have AQ for an aqueous acid, and here we have no information at all. In this class, if they don't tell you what kind of acid you're dealing with, then you are to assume that it's aqueous, and you'll use this rule to name it. Let's try and name the first one here using our first element metal rule. So we're right here in the flow chart. You say the name of the first element, stem of the second element, and then IDE. Alright, so the name of the first element is hydrogen. The stem of the second element is chlor, and then we finish with IDE. Okay, so now let's use the new rule to name our aqueous acid. We're going to start by saying hydro, then we're going to say the stem of the second element, which is chlor, then we're going to finish it off with ic acid. So altogether we have hydrochloric acid. Okay, as you'll notice, none of these have whether or not it's a gas or aqueous. So we assume aqueous and we use our new rule for acids. Let's do the first one together. The first thing we're going to say is hydro. Then we're going to say the stem of the second element. Now up to this point, phosphorus has been in a salt, and its stem has been phosp. But when phosphorus is part of an acid, the stem changes to phosphor. And then we add ic acid. So altogether we have hydrophosphoric acid. Okay, let's do the second one. The first thing we're going to say is hydro. The second thing is the stem of the second element. Now up to this point, sulfur has been part of salt, and its stem has been sulf. But when sulfur or carbon are part of an acid, it says its full name, so we'll write sulfur. And then we'll add ic acid to the end. So altogether we have hydrosulfuric acid. Okay, you take a second and do the last one on your own. Okay, the first thing we did was write hydro, then the stem for bromine is brome, and then ic acid on the end, so hydrobromic acid. Hopefully those weren't too hard for you. Alright, up to this point we have been going consistently from the formula to the name, but now we need to do some practice on going from the name back to the formula.
Back to formula.
Okay, so I have tried my best to include one of each kind of situation that we've looked at so far. Alright, the first one, sodium phosphide. It ends in IDE, which means this is a binary molecule. So there's only 2 elements present. So the first element is sodium. So we're going to write the atomic symbol for sodium, which is Na. Then the second thing we look at is the stem here, phosp. That leads us to the second element being phosphorus. And then we go all the way back to the very beginning of this video, which is how to crisscross and reduce. If we have 2 elements that we want to create a compound from, we need to get their oxidation numbers. So sodium has a +1 charge, and phosphorus has a -3 charge. Now we just simply crisscross and reduce. So we bring the 3 down to sodium and the 1 down to phosphorus, but you don't have to write the 1. So that's the correct answer for the first question. Okay, the second question, gold 1 silicide. Okay, IDE indicates that this is a binary molecule. The first element is gold, so we'll write down the atomic symbol for gold, which is AU. Now, the Roman numeral 1 here is indicating that the first element, gold, has an oxidation state of +1, so we'll write that down. Then we look at the stem here, silic. That's indicating that the second element is silicon, so we'll write silicon down. And then we need the oxidation state of silicon. Well, it can be plus or minus 4. Since silicon was written second in the name here, it's the anion, which means it's going to have the -4 oxidation state. Now we'll just crisscross and reduce. So we're going to bring the 4 down to gold, and we're going to bring the 1 down on silicon. But we don't have to write it, so this is the final answer. Okay, the third question, dinitrogen hexafluoride. IDE, again, indicates that this is a binary molecule. Di is a prefix for 2, and the first element is nitrogen. So we're going to write nitrogen, and there's 2 of them. Then we have hexa, which is a prefix that corresponds to the number 6, and fluor is the stem for fluorine. So we'll write fluorine's atomic symbol and 6 so that we have 6 of them. There is no crisscrossing and reducing in this one because it starts with a non-metal, and in the non-metals we just use prefixes. Okay? In question number 4, we have IDE, which again tells me that this is binary, and we have cupra, which is the stem for the Latin name of copper. So we're going to write down copper's atomic symbol, Cu. Then we have ic. Ic is telling me that it's got the higher oxidation state. Well, I remember that copper can be +1 or it can be +2. So the higher oxidation state was the +2 version, so I'll bring that over here. Okay? The next thing I have is nitr, which is telling me that the second element is nitrogen. The only possible oxidation state for nitrogen is -3. So I'll crisscross and reduce. So I have Cu3N2. Okay, now we have our last question, number 5. I had to switch that out. I realized I gave you all the formula instead of a name. So here we see that we have an acid, which indicates that it must start with hydrogen because all acids start with hydrogen. It has hydro in front, which means this is a binary acid, so there's only 2 elements. So we'll write down hydrogen first, and then we have iode as our stem. That indicates iodine as the second element. Okay, now we need the oxidation numbers. So hydrogen's a +1, iodine is a -1. So when we crisscross and reduce, we just get Hi. Okay? Those are all of the possible situations that I can think of. I guess the only other one that I didn't do is if I said this is a gaseous deal, and in that case we would need to say hydrogen iodide, and if we did that then we would get the same formula here, except we would put a little G down here so that we know that it's a gas. Okay? Alright, so you have now learned all of the possibilities for binary compounds. You can name every binary compound in the whole world. Okay? So what I want you to do is to practice, use your flow chart. That'll help you while you're still learning everything. And if you have any questions from your homework or any of the practice problems, come see me for tutorials. Alright, as always, thank you so much for learning with me today, and I will see you next time.